Hey guys, welcome back to Data Mining and Predictive Analytics. I am Dr. Bolton, and today we're going to continue our discussion on SQL statements and creating queries within the SQL programming language. Specifically, we're going to start talking more about SQL select statements. Remember, select statements are really part of our data manipulation language. This is after our database has been created, our tables have been established, we've established all the rules and schema for our database, and now we want to go in and manipulate our database. Maybe we have some data already in these tables, and we want to actually start querying these tables to extract information for it from these tables so that we can go on and do more advanced stuff with it, right? And so the select command is really how we do that, how we access that information, how we manipulate that information. It's got several different clauses that we're going to discuss today. And really, it's how we access the information in our database, in our tables, and create more specific views of exactly what information we want to see. Select statement always has the select command as its first clause. And that's how we access which tables we want to manipulate or we want to access. The from clause the select function is going to allow us to identify what columns within the table that we want to access and manipulate. The from clause allows us to identify what table we want to access. All right. And so select. The next statement is from which columns we want to get access, and then from which table we want to access. And then where is the conditions in which we want to actually place for accessing that information. So typical select statements from our last discussion returns a select set of rows when it's executed. So if I have a query where which products have a standard price less than $275, I might have a query that looks something like this. Select the columns that are called product description and product standard price. All right, so those are two columns that exist in this table called product T. All right, so from the product T table. All right, columns, table. All right, where, all right, here's my condition, where the product standard price is less than $275. All right. And so here you get a result, all right, that is the two columns that we specified, the description and the standard price, all right. And then these come out of the product T table, and then my results are the rows, all right, in which I have product standard prices less than 275, all right. We're going to talk more about these wildcards that exist, but there are special keywords and wildcards that can be placed in this statement to make it more selective, all right, and really drive home this idea of creating queries for very specific applications and looks. So again, I'm going to show you guys a lot of examples today. Here's one. Remember, the wildcard for the asterisk here is select all of the columns, all right. So give me every column that's in the table. So if I have a select statement where it says give me all the columns from the book table, I'm going to get some result that looks like this, where every column is being returned back from that book table, all right? And then I'm seeing all of my rows that are in the book table. Another more specific one would be, let's select just the columns of book ID and the title, all right, column from the book table. So then I get a column that is called book ID and the title column that is in that table, all right? And then I get the rows back from that, all right? And then here I can make it a little bit more specific, all right, where I'm saying where I only want to look at where book IDs are B1, all right? And so now I have the book ID column, the title returned back, all right, but I'm only looking where the condition of the book ID column is actually equal to B1. That's how I read that. So some more examples. All right. All right, so a little bit more about these wildcards. So what if we don't know exactly what value that we want to specify in our where clause? So maybe I don't know what condition I need. All right, but maybe, for instance, I don't remember what the name of the author is, but I know their first name starts with an R. Okay, and so the where clause is going to require any predicate that can be returned back as a true, false, or unknown. All right. And so I can use a like predicate in the where clause, right, to search for a particular pattern in the column. And then I can add a wildcard. All right, here I'm using the percent sign that's used to identify any collection of missing letters. All right, so here's my where clause. I only know that the first name starts with R, so I can say, okay, well, first name column is like, and then I have the R, and then I put the percent sign for any letter after that. So this is going to return back anybody in that first name column that has a first name starting with R. All right, and here I get 2. So we can add these wildcards. We can add these percent signs either right after a particular character, all right, or I can add it before the particular character. In this case, they can be patterns as well, so they don't just have to be character. They can be numbers and numerics as well. All right, or I can add it before and after. Maybe I only know that it had 2 R's in the name or something like that. All right, and so these wildcards can be placed in the where clause to help us identify information in the rows as well. All right. Comparison operators, we talk a lot about these in not only SQL but other programming languages. So I'm hoping that this isn't the first time you guys are hearing about comparison operators, but this allows us to be able to compare different operations within the where statement. So we can use comparison operators with SQL not only with numeric data but also character variables and date variables. All right. And so if I have a query that says which orders have been placed since 10/24/2015, I can write a select statement that looks like this. Give me the order ID column, the order date column from the order table where the order date column is greater than 24 October 2015. All right, so in this case, I'm using the greater than comparison operator. All right. There's a list of all of these comparison operators in Table 6.3 of our textbook. And so if you're interested in learning more about these and which syntax, because some languages use double equal signs, there's other varying syntax within this as well. For SQL, this is what the comparison operators look like. It is worth noting that dates can be very tricky. Especially working within a database management system. A lot of them allow you to specify what the syntax of a date will be, whether it's year, month, day, month, year, whatever syntax is used for that particular date. It just would, when you're creating databases or extracting databases, you either need to know how that is actually syntaxed, or make sure when you're creating a database that you're consistent across all of your tables. All right, and so make sure that if you're using dates within your tables, make sure you're using consistent syntax for your dates. Otherwise, this will mess you up quite a bit when you're trying to query tables on dates. This is just another example showing you of the not equal to. So this is what furniture does Pine Valley carry that isn't made of cherry. All right. So we have a product description, a finish from the product table where the product finish is not equal to cherry. So just another example of using those comparison operators. There are also logical operators. Logical operators allow us to join 2 or more conditions or negate conditions. And so an AND operator allows us to join 2 or more conditions and returns the results only when all of those conditions are true. All right, where an OR operator allows us to join multiple conditions and returns results when any of the conditions are true. Not obviously negates the expression. So here's an example of us querying a list of product names, finish, and standard price for all desks and all tables that cost more than $300 in the product table. Might look something like this. Select the product description, finish, and standard price from the product table, where our product description all right, anything before and desk, all right, or the product description that is like anything with the name table in it, all right, and it's got to have a product standard price greater than $300, right? So this is how we might think that we're going to write this, right? So we can have multiple operators or combined operators within our where clause, all right, and should return back. But if we notice here in our table that the computer desk, all right, is only 200. The walnut computer desk is only $250, so it's not greater than $300. So we don't expect this row to actually return back. And so why is that? Well, if multiple operators are being used, all right, they're evaluated in a very specific order, all right? Not as evaluated first, and then or, all right? In this particular case, we don't have a not operator, so the and value, or the and operator gets evaluated first, and then the or statement. So actually, the first time this runs, the product that has the word tables in it and the product standard price greater than $300 gets evaluated first. All right, so that gets linked with that. And then in the second evaluation, the desk at the or gets anything before the or statement gets evaluated. And so what this causes is that we don't get to actually look at the desk returns that are actually greater than $300. So it's returning back anything at value, all right, for our products that have the word desk in it, all right. So this is very, interesting, and we have to be aware of how these Boolean operators are evaluated in our where clauses, especially if we're having multiple statements in here, all right. So we have to be aware that they're not going to work always in the standard order of operations. Now you can force these, so if we wanted to actually force how this logical operator will work, we can use parentheses to separate how those are evaluated. So in this case, the same statement as before, we're just adding these parentheses into our statement. So now the product description that has anything with desk and anything with table is going to be evaluated first, all right? And then anything greater than $300 in the standard price column is now going to be evaluated. All right, and so then this is a more accurate description of how these, how we wanted this query, how we wanted this statement to actually operate. All right, so now only the products with the unit price greater than 300 are now included. So we can also use comparison operators to grab a range of rows, all right? And so this allows us to be able to grab a whole series of rows based on specific values. We can also use keywords like between and not between to be used. So here's an example of a query where we're looking for products in the product table that have a standard price between $200 and $300, all right? Here in my where clause, I've got a product standard price greater than or equal to 200 and a product standard price less than or equal to 300, all right? Perfectly good statement, perfectly good result. This should return back any products descriptions in the product table that is in this particular range between $200 and $300. But I can also use these keywords between and not between to write this, in which case in my where clause I have the product standard price between 200 and 300. So I can use these keywords in my where clause and get the same result as I did. And notice how, I mean, this is really, up to the programmer to whether or not they want to use these keywords, but it does sometimes allow us to reduce the amount of text that we have in there and make our code a little bit more readable, okay? And so both of these will return back the same result. Distinct values, we highlighted this a little bit last time, but sometimes when returning rows that don't include primary keys, we will end up getting duplicate rows in our result. So in this case, if I'm looking for order numbers which include in the order line table, I might select the order ID, all right, from the order line table. So this should return back everything in the order ID column. So here we see this, but notice that I have repeating columns, all right, in here, all right, and that's because many of my orders have multiple items within a specific order, all right. So this was the relationship that I established when I created these tables, that there's a relationship between these two tables, all right. And so this is why I'm getting back multiple rows. Well, if I want to look at the distinct values, I only want the order IDs. I don't want them to duplicate, all right? Then I can say, all right, select distinct. Use this keyword called distinct from the order ID column and select from the order line table. And so this distinct keyword will actually only return back the unique rows that are available in the order ID column, okay? And so it's important to understand that we can use this to get distinct rows, but this can only be used once. And notice that it comes right after my select statement. It's not anywhere else. So in my syntax here, the distinct keyword comes right before the columns that I'm trying to return back and access, all right? And so, and you can only have one of these per column ID, all right? So I couldn't have distinct order ID, distinct customer name, distinct company ID, whatever. It has to be distinct. Only one of these can be a distinct unique variable, all right? I can also return back from my where clause conditions where there are sets of values. So if we want to select, in this particular case, we want to select authors where the country is AU, BR, or CH, or whatever that would be. If we were to do this using the where clause, that can become extremely cumbersome. So in this instance, select first name, last name columns from our author table where country equals AU, or country equals BR, or country equals CH, or country, we'd have to do that in our where clause. So this could become repetitive. It's definitely not good for readability in your code. So there is a in statement that we can actually add in our where clause to be able to access multiple conditions that reduces that repeatability, all right? And so this is the in clause. I sometimes think of it as like include, all right? So where country includes AU, BR, the syntax is you have to have parentheses. This is a character variable, so we have quotations here, AU, BR, all right? And allows us to specify a set of specific values in our where clause, all right? And so this will take a list of expressions that we want to now compare. So include is very helpful for reducing your conditions within your where clause, okay? This is another example of this. We want to return back the customer name, city, and state from our customer table, where our customer state includes Florida, Texas, California, Hawaii, all right? So this is another example of this. Here we see returning back all of these rows that meet these specific conditions, all right, which include. All right. We can also So the next few slides is after the where clause has operated and you have some set of results that have come back. So we can organize those results in specific ways. All right. So 3 different clauses that we can add after the where clause that will organize the results that we returned back from our conditions, from our statements in the select statement. So these kind of get tagged on at the end, and they just kind of organize how you're going to view the results. One is ordered by. This sorts the final results of those rows in ascending or descending order. So here I have select the title column from the book table. I return back the title column. I have all this list of titles that are in my book column. So if I want to display these results, for instance, in alphabetical order, because it makes it more convenient, I can use the order by clause, all right, where I'm ordering by that particular column. So select title column from the book table, and then order that title column alphabetically. So by default, the results are going to be sorted in ascending order alphabetically. All right, so we can see that. Sometimes you may not want descending, so by the default it does order things ascending. All right, if you want a descending order, all right, the opposite way, you can use that keyword descending just at the end. So order by title, and then instead of having them ordered ascending alphabetically, here we're ordering them descending alphabetically. So you see just get reversed there. All right. We can also order by 2 different columns. All right, so in this particular query, we want to return back all of these and list the customers alphabetically by state and then alphabetically by the customer in each state. All right, so here's my order by clause after my where statement. All right, so it's going to operate on my results, all right, and order them alphabetically first by customer state and then by customer name. All right, and then so we can see California and customer state is first, and then customer name. These are now alphabetical as well, and then the next series in alphabetical order, and then the next series within the customer name in alphabetical order. So then this would just continue on. All right. Sorting order is determined by the order in which the columns are listed. So we're going to start with the customer state first, and then do the customer name next. We can order by column position. So notice that here we're ordering by the column name itself. All right. But we can order by the column position within the table itself. So here I can say order by the value 2, and so it's going to order by the pages column here. So notice how these are now in ascending order according to the number of pages within here. So not exactly probably you can do this. I'm not going to say it's best practice, because actually it's better to know, all right, that which column you're actually, because now I have to know what the second column is, right? So I need to be able to understand what is 2, what is column 2. So for me, I think if you're going to use order by, specify what column it is for you. I mean, it just keeps your code a lot more organized, and it keeps readability. But you can do this by just accessing the column number as well. Group by groups the rows in an immediate resulting table where the values in those rows are the same for one or more of those columns. Group by can be helpful, especially when we start using these aggregate functions. I'll talk more about functions in an upcoming video, but there are some functions that you can use within SQL, like sum or count, which counts up the values that are in a column. And so group by can be particularly helpful when doing that, and that's what we'll look at. So in this particular query, we're going to use the group by clause. We're going to count the number of customers with addresses in each state to which we are actually shipping. All right. This is the first example of us creating a column instead of returning back a column that exists in the table. But here I'm going to use my select statement to manipulate this view. And here I'm looking to return back the customer state. But I'm not going to return back this particular column because this column doesn't exist. I'm creating this column using this function called count. So I'm going to count, all right, the values on the customer state, all right, or how many times. So this is going to count how many times this customer state appears in the column, all right. Of course, from the customer table, and we're going to group by the customer state itself, all right. And so then after our aggregate function, it just groups everything by that actual state, all right. And so this function is a column that we're actually creating, and notice that when I get my results, this becomes the column heading, becomes the column name, all right, is the count of each time that customer state appears, all right, that address appears. So CA, we end up with 2, all right. The group by just collapses everything down, all right. Florida appeared 3 times, Hawaii 1, Michigan 1, New Jersey 2, and so forth, so forth, so forth, all right. So hopefully that makes sense to you guys. So one thing about using these functions to create, and we'll talk about this more in an upcoming video, but as you create more of these functions that actually end up returning back and creating a column, right, that doesn't exist, all right, I'm creating this from my statement. I'm manipulating my database to create this particular column that I want to view, all right. Oftentimes, you don't want to have it return back and say what is the count of the customer state. Maybe you want to make it more readable and understand. Maybe you're printing this out for a boss, whatever it is, and so you want to rename this column heading, all right. You want to rename what this column is, all right. And so you can use the as clause to be able to modify the name of what this aggregated or whatever this function column is, all right. So if I'm doing this where I select the country, all right, from the author table, and I'm going to order by the first column here, all right, and then maybe add in this count country. That's what this would look like. In the second statement, I'm selecting the country. I'm creating this count country column now, all right, from the author table and grouping by our country. And now we see what my results are. I end up just with the country 2 column name here, all right. But I can use the as count or as function to rename that second column to a name that it means more sense to me. So here I'm naming it count, all right, from the author table and grouping by country. So remember that this as clause has to come after whatever function that you're creating this column with, all right. So it is before the from table clause and has to be entered right after the column that you're creating with the function. All right, so count country is the column that we're creating, and we're going to rename this as just count. All right, and that's what we see here. And then finally, having can only be used after the group by and acts as a secondary where clause that allows us to return only those groups that meet a specific criteria. So here we're adding another criteria, another condition to our statement using the group by clause. All right. And so the having clause acts like a where clause, but it does identify groups rather than rows that meet a particular criteria. So here we're restricting the results using the having clause. So we're going to select the country column. We're going to create a column that is going to have our count. We're going to rename it as count from the author table, and we're going to group by country. All right. Now, that's my results here. But let's say I only want to look at the countries here that ended up with a count larger than 4. All right. So then I have my group by country. I add the having clause after that. And then having a count country, all right, this is the function again that is going to result or is going to return back something that is greater than 4. And so then my final view, my final returned table here is a country column and a count column in which the countries that are greater that appeared greater than 6 times or 4 times are now in my resultant. All right. So in summary, lots of different ways that we can use the select statement to manipulate our database and return back different views of the relationships between different tables within our database. And for the most part, this is how you guys are going to interact with the database and the table, especially as data scientists. You're going to want to access the information that's in this database and return back, select information from that database. And this is how you're going to do it. So this kind of just wraps everything up using all of these. All right, list in alphabetical order the product finish and average standard price for each finish for selected finishes having an average price, standard price less than $7.50. All right. So a large query, you might be asking a similar answer or question when you're accessing, one of your databases or your boss's database or your company that you're working for database. So select the product finish. All right, we're going to use the average function. All right, from the product standard price. We're going to access the table from the product T table, and then here we're going to ask in our where clause where the product finish is going to include. Here we are including the cherry, the natural ash, and the natural maple and the white ash to be returned. So this is our condition for the product finish table or our column. And then we're going to group by our product finish. All right. Having an average price, so now we're going to add this additional condition of having, all right, an average price that's going to be less than 750. All right. So now we group all of these product finishes. Here we only return back 3. All right, but the condition for us to return back is that each of these groups has to have an average price of less than 750, and that's what we see here. And then we're going to order by in alphabetical order that product finish column. So these should be in alphabetical order, which they are. And there you go. All right. So this is a little bit more complex where we used all of those clauses in the that we just talked about in one complete select statement. So that's it for today. If you have any questions, please reach out to me, send me an email. But other than that, have a great day, and I will talk to you soon. Take care.